Mr. Ashok R Kulkarni. He is the founder, member, and managing director of Nikitha Buildtech Private Limited. He holds an experience of more than 32 years in business development, project management, and client servicing. He also has an in-depth technical knowledge of pre-engineered buildings, sales, marketing, and engineering design. The company has also introduced new technology in composite beams for the first time in India. Today, he will talk about new technology in construction for large span structures. So delegates, let's welcome Mr. Ashok R Kulkarni.
Good evening, everybody. This is Ashok Kulkarni, Managing Director of Nikitha Buildtech Private Limited from Bangalore. So basically, we are into pre-engineered buildings, so-called prefabricated steel structures, in which we have been doing for the last 28 years. Currently, just to mention about the steel structure, definitely this is for the fast-track projects, very much important having steel structures. Currently, we are coming out with a new technology from Turkey. So we are building an hospital project in Davangere in Karnataka itself, nine-story building where conventionally it was designed with 200 columns, but we are doing it to just 80 columns. That means only 40% of the columns we are taking. So that much of clear space we will have because of this new technology. Basically, this new technology is a composite beam structure. So there is an I-beam. I'm sure everybody will understand the I section. And below we have a precast and pre-tensioned concrete strip at the bottom, by which we will be able to reduce the depth of the beam, and also we can increase the span. So 28-30 meter span easily we can provide, even for the multi-story building. This is what is the technology we have provided, and with this we have started our construction in Davangere. That is the first ever project in our country with this, using this new technology. Of course, prior to this, we have been doing a lot of industrial projects, warehouses, and a lot more, even ROBs, road over bridges, railway over bridges, using prefabricated steel structure. We have a plant in Tumkur in Karnataka, and we are office in Bangalore. Currently, we are also doing a project for Samsung in Chennai, Sri Perambur, where almost about 6 lakh square feet we finished in about 5 months. We are in the verge of completion. Coincidentally, I am there in Chennai now in the field. I just came running out to attend this meeting. So this project, 5,000 metric tons of steel being used for almost about 6 lakh square feet. Everything was fabricated in our Tumkur plant and shipped to Sri Perambur and installed in last 4 months. So we are almost in the verge of completion. And this is the advantage of prefabricated structures, and also about the composite beams, which I mentioned to you. As I mentioned, Nikitha, we are almost a 27 years old company, having our pre-engineered division and civil construction, and also a lot of building materials, and as well as construction chemicals, including epoxy flooring. We also have a tie-up with Fosrock as well as Sika, and also the sheet profile. This is how the company is developed. This is our plant in Tumkur. Yeah, so we're having a capacity of 24,000 metric tons per annum production capacity, and we have a complete automated system, state-of-art technology plant in Tumkur, and we have a long reputation clients as well. So almost 90% of our orders are repeat orders. That is how we maintain the customers in terms of timely delivery as well as the quality, and we also maintain the standard IS codes as well as ASTM, those codes. Yeah, this is a plant in Tumkur. Now, as I said, let me not just go back to the pre-engineered building, which is already well known now in our country as well as globally. Let me just come to this composite beam technology, where we taken this help of Turkey's people to introduce technology in India. And this is how the beam looks like. You can see a I-section beam here with the studs welded on top for a shear studs for a deck slab. And at the bottom, again with the steer studs and the reinforcement, we'll have a precast concrete with pre-tension cables. Of course, it depends, number of strands, everything depends on the design and span, but the cables are put here. And then this is how it is casted, made in the factory. On left-hand side, you can see a ready-made beam which is being shipped out to the site. So this is more useful for cantilever beams as well as for the large span structures. Now, to be specific, this is the first project in India. As I said, in Davangere, we are coming out with this technology for a hospital building, where the conventionally architect design was with the 201 columns, but currently we are doing this with the new technology only with 80 numbers of columns, where we have introduced a span of 24 meter, 26 meter, like that. You can see number of columns, being reduced. The footprint of the building is about 1 lakh square feet, and it is going for about 9 floors. Yeah, this is how the beam looks like, and top will have the stair studs for the concreting, how they are being shipped out, and you can see the cross section of the beam. Yeah, this is during the installation. You can see these beams are connected to the steel columns on either end, and we can have a large span beams. And across the beam, there will be a longitudinal side. The beam spacing can be about 2 meter or 2.5 meter, depends on the load and span. And of course, there is no bar on live load. We can design for 500 kg per centimeter square, or 1 ton or 2 tons. Depends on the need. This is in Turkey, not here. It's one of the project they have for a long span. It's being shipped out in a special lorry. So all the MEP services, everything can be passed through these beams. So then there is no, in fact, when you look at this bottom, since there is a self-finished concrete surface, many places you can even avoid false ceiling. So all these MEP piping, everything can be taken within the beams. All that can be hidden. Over that, of course, as I mentioned, we can have a deck slab with a corrugated deck sheet. Over that, the concrete, depends on the design. So you can see the multiple beams here. The green one is the concrete, and the top blue one is the steel section. Over that, the deck slab. And even the sunken slab you can see here with a black mark. So this can be also maintained, for the sunken slabs in multi-story buildings. That is also possible. So as I said, major advantages are large span, and with less number of columns we can achieve. So maneuvering and the layout will be very easy. Especially in basements and all that, when you have less number of columns for the car parking, for maneuvering, it's so easy, so beautiful. We are also trying to introduce this in the apartment projects, residential buildings, where number of columns can be reduced. And of course, steel beams can be strengthened with reinforcement concrete and pre-stressed cable. Since all the beams are manufactured in the factory under controlled system, so definitely the superior quality can be achieved. In fact, the concrete is one M60 grade. So there is a high grade concrete being used, and quality is maintained. This is some of the projects which are Turkey partners they have executed in Israel and Turkey and those countries. You can see the large span cantilever beam, on the right hand side bottom. This is, if I am right, around 30 or 35 meters cantilever beam which is going up. And even for railway overbridges, these beams are very much advantageous, useful. As I mentioned, these are all, yes, you can see one of the airport, Israel airport project near that railway station, railway overbridge. So that even the curve is possible. Any radius or any curve, we can take it without any supports. You can see the structure here. I don't know about the span, but it's a quite huge span, where there are no columns at all. So there is a very easy vehicle maneuvering underneath. These are all the views of that project. You can see the concrete at the bottom. Yeah, this is some proposal they are given for the railway bridges. Yeah, of course, here also we are trying to enter national highways as well as railways, where we can reduce the number of columns, piers for the bridges, and we can have a large span. In fact, we are also approaching BMRCL for giving us one opportunity to provide this. These are all some skywalks and different designs which they have proposed in various countries. Typical bridge looks like this. You can see so many number of beams there, and bottom is the concrete and the ice section. So on top we can have the deck slab, and span can be even up to 60 meters. We can design 65 meters easily. We can design, and depth can't be like conventional. The depth of the beam can't be 2 or 2.5 meter or 3 meters. It can be well within the limit, less than a meter. That is the advantage of these beams. We can also have castellated in case we want to take any services or for aesthetics. So this is the first project which I mentioned to you. We started this is an hospital building in Davangere. This is the ultimate output elevation architect has emphasized and designed. And you can see a lot of white borders, which they are coming out cantilevered. I think 8 meter, 9 meter, like that cantilevers. All these things are designed with these kind of new composite beams. Yeah, this is a model of that. There are the A, B, and C. There are 3 blocks. So currently we have taken up A and B blocks now for construction. Yeah, this is an overview of the structure skeleton. So one more advantage is the height because of the lesser in depth of the beam. So number of floors can be achieved. So FAR, basically what we call a floor area ratio, it can be achieved. This is the plant we have set up in Davangere to manufacture these beams, composite beams. Already production is on. On left hand side, you can see a beam which is just coming out of the mold and being kept. You can also see the center camber being created because of the pretension. The moment the pretension cable is released from the mold, it is easily forming the camber on top, which will be attaining the strength, as well as, it will at the site, once it is loaded, then it becomes zero. You can see the beams on left hand side. This is during the manufacturing of these beams. You can see the cables here, stands, and the TMT bars, reinforcement, and the mold. Over that, we keep the steel beam, I-beam, and then pour concrete, M60 grade concrete. And since we are using a steam curing, within 24 hours we can achieve the minimum 60% of the strength, and hence we can take it out and then keep it out, so that the manufacturing also will be faster. This is how the fast construction can happen. You can see number of beams being kept there outside. Yeah, you can see here. These are all the beams which are manufactured and kept now. They're ready for installation. You can see the studs also, how they are being handled and carried. This is the construction site where the foundations are going on now. So probably in a month's time, we will be starting the erection of these columns and beams. The steel structure erection installation will start. Civil work is on. And this design has been approved by IIT Chennai, Turkey design. And as I mentioned again, let me repeat that this is the first time introduced in our country. So we also do not want to take any chance or risk, and then we wanted a third-party vetting and design. So where we approached IIT Chennai, and the Turkish people were kind enough to submit all the kind of design details, everything to IIT Chennai, and we finally got the approval. This is it. Thank you very much.